Okay, students. So here in the previous class we discussed about the Dalton's atomic theory. According to Dalton's atomic theory, any matter is made up of a tiny particles called atoms, right? And according to the same theory, atoms are invisible and indivisible. Means what? We cannot break the atoms. Atoms only the smallest particles. Clear? This was the concept of Dalton's theory. But later, this concept was proved as wrong by J.J. Thomson. By J.J. Thomson by discovering electron. By discovering electron. So here, students, atom according to Dalton's, it is not divisible. It is indivisible, right? But J.J. Thomson, by his famous discharge tube experiment, he discovered the electrons which are released or emitted from the atom. Means what? Atoms are divisible, means atoms can be broken, means divisible, and from that still it consists of still smallest particles inside this, right? So such a particle, the first particle was discovered by the J.J. Thomson by discharge tube experiment, right? And later so many particles were discovered, we discuss later, but in that among them the important particles or which can influence the atom physically or chemically, the important particles are three particles. Okay, they are electrons, protons and neutrons, right? And these three are called subatomic particles. What they are called? Subatomic particles, right? So today we are going to discuss about the first subatomic particle which was discovered. Okay, that is electron, right? And this was discovered by whom? J.J. Thomson, right? So students, today we discuss about the J.J. Thomson's discovery of cathode rays. Discovery of cathode rays. So students, here this cathode rays were discovered by J.J. Thomson. Okay, discovered by J.J. Thomson from his discharge tube experiment. Okay, what is discharge tube? Now let us see here. So here discharge tube is nothing but it consists of one long glass tube. It consists of what? One long glass tube. So see here, this is like this. Okay, so this is a long glass tube. It's a glass tube, alright? And here is one small opening. This is the opening, okay, like this, right? And this glass tube is a glass tube, and here it is fixed with the two metal rods inside. Two metal rods, okay. So let us take, this is one metal rod, okay, and I'll take here one more metal rod, like this, two metal rods, okay. And these two metal rods are connected to the high electric potential, okay. So like this, alright, like this, alright. So here this is a like source of electrical energy, very high energy, okay. So here it is a positive terminal, this is a negative terminal, right? You know, no? Here two lines are there, symbol of a cell, this is a symbol of the cell, and it is a positive terminal, here it is a negative terminal, okay. Here one big line is there which is called Bade Miya, he is positive, and one more Chote Miya is there, he is negative, right. Now here the two electrodes are there, these two electrodes. Then these two electrodes, these are called electrodes. The metal rods which are connected inside, they are called electrodes. What they are called? Electrodes, right? Now, here the electrode which is connected to the positive terminal is called anode. What it is called? Anode, right? And here this electrode is connected to the negative terminal, and this is called cathode. What is called? cathode. And under normal condition, here this glass tube is filled with the air. It's filled with what? Air or gas. And under normal condition, you know that the pressure, okay, normal atmospheric pressure is how much? In terms of barometer, if you measure, like, what is the pressure? 1 atmosphere, right? So 1 atmospheric pressure is equal to 76 centimeters of mercury, right? So 76 mm normal atmospheric pressure, or we can write the normal atmospheric pressure is 760 millimeters, because 1 centimeter is equal to 10 millimeters, right? So like this, 76 centimeters means what? 760 millimeters. So inside the pressure is 760 mm initially. Imagine that, right? Now, so here he started passing the electricity. Okay, we arrange one switch also here. So let's take this is a switch, and now he switched on. On switching on, what happens? The electric current flows through this one, right? So when the power is connected, then here what happens? Initially, nothing was absorbed in the discharge tube, this tube. Okay, why? Because inside what is there? Gas is there. And you know that gases are bad conductors. Gases are what? Bad conductors of electricity. So nothing was observed under normal condition, right? Then what he did? He removed the gases, okay, from this, okay, by operating the vacuum pump. So this is fixed with the vacuum pump. So let's call this, okay. So here he operated with the one pump which is called as a vacuum pump, okay. So vacuum pump, right. So this vacuum pump, okay, removes the energy, means take out the energy from the discharge tube, right. In that way, he started decreasing the pressure inside the glass tube, and at the same time he increased the voltage here, okay. So here approximately the pressure was maintained, okay, the inside the this one, the glass tube, the pressure is maintained almost 0.01 mm of mercury, okay. How much pressure? 0.01 mm of pressure. So from where? 760 mm to he removes the air, okay. So like this, by using the vacuum pump, and as the air is removed from that, then what happens? The pressure inside the glass tube will be decreases. Yes or no? So in that way, continuously remove the air and maintain the pressure of how much? 0.01, means what? Very low pressure is maintained. Okay, so this is very low pressure, and here the voltage is maintained greater than 10k. 10k means what? 10,000. Okay, right? 10,000 volts, almost 10,000 volts. Okay, you know 10,000 volts is very high voltage. Okay, so for example, if you see, the government will be supplying the voltage to us, our houses. Okay, this is only about 240 volts, 230 to 240 volts, right? So with this 230 to 40 volts, we are running everything, right? So but here he arranged the voltage is about 10,000 volts, very high voltage. So under these conditions, under which conditions? Low pressure and high voltage, low pressure, okay, and high voltage, some rays are released or emitted from the cathode. Okay, from here the cathode, this is called cathode. From this rays are started emitting. This cathode started emitting the rays. So from the cathode, some rays are observe that these rays are moving towards the anode. Okay, some rays are produced here, and these rays are moving towards the anode. So like this, they are moving from cathode to anode, right? So from where they are producing the rays? From the cathode. And where they are moving towards? Anode. So as they are moving, releasing from the cathode, means from here, these rays were named as cathode rays. How they are named as cathode rays? Clear to you? These are named as cathode rays. Why they are named as cathode rays? Because they are originating from the cathode, right? When you are maintaining the very low pressure and a high voltage. Conditions of what? Pressure should be low and voltage should be high. Under these conditions, a rays are released from the cathode, and he named this rays as a cathode rays. Clear to you, the cathode rays? Any doubt? Right. So first, initially he thought that these are the rays. These are the rays. But later he observed that he came to know that after some experiments, he came to that these are not a rays, but these are the flow of negatively charged particles. What are they? They were not a rays, but they were a negatively charged particles. Okay, so these are not a rays, but these are the particles, and these particles were named as electrons. Okay, so later these were named as what? Electrons here, right? So these are not a rays, but these are the particles. Particles which are later named as electrons. How they are named as electrons? Clear to you, students? So this, by this experiment, J.J. Thomson discovered the electrons. Any doubt? So once you see the setup and see the board, try to understand. So once again, I'll explain you. Listen carefully now. According to Dalton's atomic theory, atoms are indivisible, right? But here J.J. Thomson disproved that theory. Means what? He proved that that theory was wrong by discovering the electrons. So atom is not the smallest particle, but atoms still consist of some particles inside. Okay, so first particle was discovered by the J.J. Thomson by his discharge tube experiment. Later, some more particles were discovered, but among them, the most important particles are three. They are called electrons, protons, and neutrons. Okay, these are the three particles are called subatomic particles, right? And these subatomic particles, so here you can see in this way they discover the electrons. Okay, so this is a discharge tube experiment. It's a consist of a glass tube, and here there is one vacuum pump will be arranged, and here two metal plates are arranged which are called as electrodes, and these two metal plates are connected to the high voltage, so they are called like positive and negative terminal. The electrode which is connected to the positive terminal is called anode. The electrode which is connected to the negative terminal is called a cathode, right? And normally the initial pressure was very high. Under very high pressure, you know that gases are the bad conductors, so nothing effect was there. But then he removed the gas from the tube. So then what happens, as the gas moving out, the pressure inside the glass tube decreases. In that way, he brought the pressure 0.01 mm almost, means what, the pressure is very low. At the same time, increase the voltage, so that's about a 10,000 voltage. At that time, he observed that some rays are emitted from the cathode and moving towards the anode, and he gave the name to this one as a cathode rays. But later experiments have proved that these are not a rays, but these are the particles. Which particles? Negatively charged particles. And these particles were named as electrons. Clear? Right. Now, let us see what are the characteristics of this cathode rays or electrons. Okay, students. Now, let us see now what is the next topic. So, here, students, these are the cathode characteristics of the cathode rays. Now, first one. The cathode rays travel in a straight line. What is the first one? Very simple one. That is the cathode rays travels in a straight line. Okay. So I said that these are starting from cathode and they're moving towards the anode like this. Okay. So they're moving in a straight line. How can you see this? They are moving in a straight line. Okay. If you place some opaque object in front of this one, then what happens? It can form the shadow behind. Yes or no? So for example, the light is falling on me. Okay. If I put my hand something, okay. So then what happens? I'm like opaque object. Opaque means what? Which can stop the light. So if I'm standing like this in front of the light, so what happens? A shadow will form, okay, behind me. Yes or no? So here the meaning is what? Light rays are traveling straight to me. Okay, they are not traveling like this. They are coming here. So when you, for example, you are riding a bike or you are riding a cycle. Sorry. Okay, you are riding a cycle. Your 7th class students don't ride the bike, so it's not so according to rules, you should not, without a driving license, you cannot drive the bike, right? Okay, so you are riding the cycle, for example, you think bicycle, and someone came in front of you. Then what you do? Then you can take a turn and you can go. Okay, you cannot go straight, no? So you can go if someone comes. For example, you are coming like this, I am here, then what you do? So then you can turn, okay, you can take a turn like this, okay, and you can go, right? But yes, can the light particles can go like that? No, they can come straight and they hit me, right? So as I'm an opaque object, then what happens? Okay, so here backside the shadow will form, and remaining all parts the rays are going and yes, okay, passing this one. So here when opaque object is kept here, okay, then what happens? Shadow is formed behind that object, right? The meaning is what? That rays are traveling straight, right? So here also, Thomson what he observed is, if he placed one, okay, he placed one cross here, okay, he placed one cross here, like this, he placed one cross. So on placing the cross, then what he observed? Here he observed that, okay, here the shadow of the cross is formed behind this, okay, behind this one. If we arrange the screen, we can see that a shadow is forming behind this one. So shadow is forming behind this one means what? The rays are passing in straight. Yes or no? So they are passing straight. So in this way we can say that okay, cathode rays travels in a straight line. So that is the first property. So first property are what? So cathode rays properties, characteristics of cathode rays. Right? So first one, cathode rays travel in a straight line. I am not writing total point, just straight line. Remember this one that they are moving in a straight line. Clear? Can you able to see or not? No. A little bigger, right? Okay, they travel in a straight line. That's the first property. Okay. Now second is what? They contain material particles. Okay. So now as just to know what I said, that these are not a rays but these are the particles. These are not a rays but these are the particles. How we came to that these are the particles. Okay. So what he has done is he arranged one very light wheel in the path of okay, cathode rays. Now we are what he kept. He arranged one wheel. What is a wheel? You know a wheel? Chalo, wheel. Like this, I can arrange just okay, like this will arrange. Yeah. Okay. So I think this is wheel, right? So he arranged the wheel in the path of the cathode rays. Okay. So here you see, if these are the only rays you think, if they are rays, they are not a particles. Okay. Can rays will have the energy to rotate the wheel? No. For example, your sunlight is there. Okay. From the sunlight, the rays are coming. Now, in front of the sun, just if you keep one wheel, okay. Now, does the wheel rotate? No, it cannot rotate. Yes or no? Yes or no? Rays cannot make to rotate the wheel. Okay. But you observe that here, when these cathode rays are striking, then what happens is the wheel started rotating. Okay. So normal rays cannot rotate the wheel. Normal rays cannot produce a mechanical energy, right? But here the wheel is rotating. The meaning is what? These are not rays, but these are the particles. These are the particles. Particles can rotate. Okay. So particles can rotate the wheel, right? So for example, you see, if you know, like the flow of water is there, you think, just flow of water, and if you place one small light wheel there, so the water is falling on it, then what happens? The wheel rotates, yes or no? Okay. So in this way, wheel rotates only when the material particle, means matter, okay, the material particle hits to the wheel, that can produce a mechanical energy, that is creates a motion. Is this clear to you? So rays cannot create the motion. So but here the wheel is rotating. The meaning is what? These are not a rays, but these are the particles. What are they? Particles. So cathode rays are material particles. Clear? So these are what? Material particles, right? Now let's come to the third point, effect of electric field and effect of magnetic field. Effect of electric field. So here we see now, here the rays are passing straight, okay. So these particles are passing straight, just now we discussed. Okay, they are passing in a straight line. They are passing in a straight line. Now, what he has done, this J. Thomson arranged two electric plates. Okay, so he arranged what? Two electric plates. Like for here, for example, he arranged a positive charge, and he arranged metallic, negative charge like this. Means what? He arranged two plates. One is above, one is below. One is above, one is below the tube, and this plate is connected to the positive terminal of the battery or source. This is connected to the negative terminal of the source, right? Now what happens? So this is a positive charge, this is a negative charge, right? So before, if it is not there, then what we observe, the rays are traveling in straight, right? But here when he arranged the electric plates of positive and negative terminal on both the sides of the cathode rays, he observed that these rays, instead of going straight, they are deflected towards the positive charge. Where they are deflected? They are deflected towards the positive charge. So instead of moving straight, now what happened? They deflected towards the positive charge. Okay, instead of moving straight, they are deflected towards the positive charge. Why they are deflected towards the positive charge? Because you know that like charges repel, unlike charges attracts. Yes or no? Did you study this one? For example, if it takes two magnets, I'll explain it with the two magnets. You know that two magnets are there, you think. These are the two magnets. And say this cap side is north pole and this side is south pole, you think. Here also this magnet cap side is north pole, this is the south pole. Now, if I bring the north pole and towards the south pole of the magnet, I think this you might have done so many times, okay. So then what happens? These both get attracted. Yes or no? These both get attracted. If I bring both the north poles together, does they attract? No, they repel. Now you have to apply the force to bring, okay, to close it, still they repel with each other, right? So why? Because these both are the north poles, means same poles, means like poles. So like poles repel, unlike poles attracts, right? So similarly, here also electric charge also charges are of two types, you know that. One is called positive, other one is called negative. So here what happens? Like charges means positive or negative repel. But unlike charges attracts means positive attracts the negative and negative attracts the positive. So like this, opposite charges attracts. So here they are deflecting means what? Here these are attracted towards the positive charge. They are attracted towards which charge? Positive charge. They are attracted towards the positive charge means what? They are negatively charged particle. Yes or no? They are attracted towards the positive charge means what? They are negatively charged particles, because opposite charges attracts, right? So by this one we can say that cathode rays deflects in the electric field, right? Now instead of that, if you positive and negative, instead of that, if we arrange the magnetic field, means what? One side the north pole, one side the south pole. Now how we kept like positive and negative? Instead of that, we keep the north pole and south pole. Okay, then also the rays will deflect. Means what? These cathode rays, okay, the cathode rays, okay, will be deflected, okay, deflected by electric field, and they can also deflected by magnetic field, okay, magnetic field. Clear? So they are deflected by the electric field, they are also deflected by the magnetic field, right? So now heating effect. So heating effect means what? Can they produce a heating effect means what? Here for example, if I place some metal plate here, I said you that they are striking to the metal plate and creating the motion in that. Yes or no? So that is creating. Now this when they strike, can when they strike to this metal plate, whether this metal plate gets heated? Yes. Okay, the metals get heated. Okay, so they can produce a heating effect. Right. Now, next one is what? Penetrating power. Penetrating means what? Passing through the material. Okay, passing through the material. Okay, that's called like X-rays. You know, X-rays. You know X-rays. For example, if you have, for example, if there is a fracture in our hand, you think, then if you take the X-rays, then what happens? The X-rays will pass through our skin, enter into the till the bones, right? So here passing through the material, they are called penetrating. And this cathode rays means what? These cathode rays can penetrate to the thin sheets. Okay, so these are the characteristics properties of cathode rays. Yes, students, is this clear? Any doubt? So once again, see here, they are traveling in a straight line. They are a material particle. They are not a rays, and they are deflected by the electric field. They are reflected by the magnetic field. They produce a heating effect. They penetrate. Okay, produce a heating effect. Okay, and they penetrate. Penetrate means what I said? Pass through the material. Clear? Right. Now, let us come to the cathode to mass ratio. Okay, mass ratio of an electron, the charge to mass ratio. Okay, so here the charge, I said that these are negatively charged particle. I said that they are negatively charged particle. The meaning is what? They have some charge. But what is exact charge? That was not calculated. That was not calculated by the J. Thomson. Okay, this total experiment was done by the J. Thomson. Remember, I didn't write the name only here. J. Thomson. Right, no problem. So J. Thomson. Okay, J. Thomson did not say what is the charge. He said that negative charge, but what is its amount of charge? He could not explain. And electrons are the particles. Every particle has a mass, so this also it has a mass also. But he could not explain what is its mass also. Okay, but he could able to calculate the ratio of charge to mass. He could able to calculate the ratio. Okay, ratio of a charge to mass means what? Charge by mass. Okay, that's called charge to mass, and it was found to be 1.76 into 10 to the power of 8 coulombs. Okay, 1.76 into 10 to the power of 8 coulombs per gram. Okay, per gram. Okay, this was the ratio of a charge to mass found by the J. Thomson. Okay, but individually did not able to calculate the charge or not able to calculate the mass, but charge to mass he calculated. Right. So with this, I think writing is done. Okay, students. So remaining part we can complete in the next class. Until, take care. Bye. See you in the next class. Oh, are you joined? Good. So I hope I thought left. Okay. So students, now, so you calculated the charge to mass ratio, that is 1.76 into 10 to the power of 8 coulombs per gram. Clear? Right. Now, after that, okay, but later Millicon was another scientist who calculated the charge of only charge of electron, and the only charge of electron calculated by the Millicon. It was found that the charge of electron is equal to 1.602 into 10 to the power of minus 19 coulombs. How much the charge was? The charge was 1.602 into 10 to the power of minus 19 coulombs. Okay, this is a charge on the electron. This is a charge of electron, very, very important. This value you have to remember. This is constant. Okay, so electron charge. If anyone asks you what is the charge of electron, so of course charge is on one negative charge, so 1 unit of negative charge, but still you need to say that what is its exact value? The exact value of the charge of electron is 1.602 into 10 to the power of minus 19 coulombs. Clear to you? Right. Now, by using this charge, we can able to calculate the mass of electron also. We can able to calculate mass of electron, and mass of electron is found to be 1.66 into 10 to the power of minus 24 grams. Student, this is also very important. Okay, so here we know the charge. we know the charge. We know the charge to mass ratio, that is this one, right? Now, in the place of charge, if you place this one, okay, if you write this one, then this become this by, okay, now I'll write the charge by mass. Mass I'm taking that side and I'm bringing this side. So this becomes what charge. Charge is equal to 1.602 into 10 to the power of minus 19 coulombs divided by, so here's cross multiplication. This I'm bringing here 1.76 into 10 to the power of, okay, 8 coulombs per grams is equal to, this becomes a mass, right? This becomes what? A mass. Now, based on this calculation, based on the calculation of this one, the mass of the electron is found to be 1.66 into 10 to the power of, okay, so the mass of electron is found to be 1.66 into 10 to the power of minus 24 grams. Okay, so that's all about the electron or discovery of cathode rays. So today's topic, with this we'll stop, right? And this is very important topic. Okay, so because from here actual atomic structure starts. Till before that, what we studied, only atoms are indivisible. Okay, we don't know anything about the atom inside what is there, but from here, okay, we come to know that atoms can be divisible. Atom consists of, okay, some other particles also, and those particles consist of positive, negative, neutral particles are there, and this is all how these particles will be present in an atom, how they are arranged. This is all we are going to discuss, the atomic structure. Atomic structure is structure of atom. How? The atom. So atomic structure is nothing but the distribution of mass and charges in an atom is called atomic structure. So from here actually our atomic structure starts. Clear to you? So student, this is very important. Hope you understood this one. And after going home, revise this all from your material, or the material is given. So perfectly read it. Okay. So with this we stop our class today. Okay. Bye. See you. Take care.